Alright, so in this video, I'm going to be teaching you guys how to solve the equation 1 to the power of x is equal to 2. Now, I know what you may be thinking. 1 to the power of any number is itself 1. So how can 1 to the power of a number equal 2? Well, there is a method to solving this. So first off, let's take the natural log or ln on both sides. So I'm going to do ln 1 to the power of x is equal to ln 2. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front, so I get x times ln 1 is equal to ln 2. Now, ln of 1 is equal to 0. So I get x times 0 is equal to ln 2, meaning 0 is equal to ln 2. However, ln 2 is equal to 0.693, so this is false. So this method does not work, the usual method of solving exponential equations. Now what I'm going to do is use an important formula known as Euler's formula. So this formula states that if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but let's walk through it. So what if theta is equal to 0? Then this means that I got e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. And cosine of 0 is equal to 1, and sine of 0 equal to 0. So I get theta is equal to 2k pi. Now, if this is true, then e to the power of I times 2k pi is equal to 1. So, because this statement is true, then doesn't this mean that our original equation was 1 to the power of x equals 2, and this is equal to 1. This number right here is equal to 1. So we can say that e to the power of I times 2k pi to the power of x is equal to 2. All I did was substitute in that for 1. Now, if we solve for this, we should get our variable x. So what I'm going to do is I'm going to do the same thing I did the first time. I'm going to take the ln, or natural log, on both sides. So now I get ln of e to the power of I times 2k pi to the power of x is equal to 2. Now, if I have something in the form ln a to the power of b, this is equal to b times ln a. So I can move x to the front, and this is going to equal x times ln e to the power of I times 2k pi, which is equal to 2. Sorry, ln of 2. Now from here, this is the same thing as I times 2k pi times x times ln e, because I can again use the natural logarithm formula and bring this to the front. And this is equal to ln of 2. And if you guys already know, ln of e is simply equal to 1. So now I get I times 2k pi times x is equal to ln of 2. Now if I divide both sides by I times 2k pi, these two cancel out, and I get x is equal to ln 2 over I times 2k pi. Now I'm going to multiply both sides by I over I, which is equal to 1. So now I get x is equal to ln 2 times I over I times 2k pi times I. And I times I is I squared, and I squared is equal to negative 1. So now I get x is equal to negative I times ln of 2 over 2k pi. So this is my answer to this equation. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900. Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8, so I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible, and we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front, so I get negative 9 to the power of 900 times 8, and this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that states that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye.